Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to this channel and leave a like for this video. Now, in today's lesson, I am with my physics class. So this basically is the midterm test. And I just figured that I just ran them through on how they were supposed to answer these questions. So this is the midterm test, and yeah, so if you're new here, remember to subscribe and enjoy the lesson. Okay, so we have the first question here that asks us to define what a force is. So basically, if you defined a force as a pull or push on an object, I would give you a mark for that. So you just define a force as a pull or push on an object. I would have given you a mark on that one. So that is how you're supposed to define that. State Hooke's law. So Hooke's law basically states force is directly proportional to extension. Directly proportional to extension. So that is how you're supposed to do this one. Force is directly proportional to extension. We'll go to question 3. Explain how mass affects the acceleration of an object. So you have 3 things there. So we have mass, we have acceleration, and force. So you know that this must have been gotten from the formula force is equals to mass times acceleration. Now, how does mass affect acceleration and force? Okay, so basically we know that mass is equals to force over acceleration. Okay, now what you're supposed to do here is explain in terms of acceleration, then also explain in terms of force. Okay, so here in your explanation, this is how you're supposed to work out this one. You just, so number 1, more mass means more force. Okay, this is because mass is directly proportional to the force applied. Okay, then secondly, in terms of acceleration, more mass, less acceleration. Okay, more mass means less acceleration because mass is inversely proportional. Inverse means the opposite. If something is more, this one will be less. If acceleration is more, means that mass is less. So more mass means less acceleration, and less mass means more acceleration. So this is how you're supposed to answer this question here. Okay, now we move on to question 4. So yeah, so it was just as easy as that. Question 4 asks you to calculate the force required to accelerate a 2000 kg truck for a distance of 7 kilometers for 3 minutes. So here you need to write out your data. So data, what do we have on our data? So on our data, we have mass, which is 2000 kgs. Here we have distance, which is 7 kilometers. So we need to convert this into meters, which is basically 7,000 meters. We also have time, which is equal to 3 minutes. Of course, this has to be converted to seconds, which when you convert will basically be equal to 180 seconds. Okay, now we are asked to calculate the force. Okay, so we are asked to calculate the force. We know that force is equals to mass times acceleration, but we don't have acceleration, so we need to calculate the acceleration. So basically I'll do it from here. We know that acceleration can be calculated using distance and time. So remember those four kinematics equation that we looked at. So among those is distance is equals to ut plus half at squared. We consider the initial velocity to be 0, meaning that this would be 0. So this is basically equal to half at squared. Okay, and we'll use this formula. So our x is the distance, which is 7,000 meters. So we're going to say 7,000. Let me see if we can write it. So say 7,000 meters is basically equal to half times acceleration, which is what we're looking for, times time, which we have, which is 180 seconds squared. So we simplify this. This will be multiplying 2 times 7, that will be 14,000 is equal to, this is our A, which equals to A times 180 squared. So that is basically 32400. Let's see. That is 32400. So we divide by 32400 to 400. So this cancels. 14000 divided by, so that will give you 0. That will give you an acceleration of A equals to 0.432, okay, meters per second. So you have your acceleration. Now you can use your acceleration. So you could have copied that. So let me see if I can, yeah, so you should have copied that. So you have that acceleration. You can rewind the video to copy that. Then you have your acceleration. Now you can calculate your force. So force is equals to mass times acceleration. Our mass is what is our mass? It is 2,000 kg. 2,000 kg times our acceleration, which is this that we've calculated here. So 0.432, and you get a force of 864.1975 newtons. Okay, so approximately it should be in that range, because I didn't just punching directly from the calculator, so it comes out directly like that. So this will give you 864.1975 newtons. So that is how you are supposed to calculate this one. Yeah, so let me just run you through. So the first thing that you're supposed to do is recognize that you're supposed to use the formula force is equals to mass times acceleration. You collect your data, so you have your mass there, you have your distance, you have your time, you have your mass, but you don't have acceleration, so you needed to calculate acceleration. So you use the formula x is equals to half at squared when initial velocity is equal to 0. When initial velocity is equals to 0. So this remains like this. So you replace your distance there and your time there squared, then you simplify and it gives you the acceleration that you need here. You replace and move on from there. So that was question number 4. We go to question number 5. Okay, question number 5, we have Kingsley lifts a box of mass this to a height of that. Calculate the potential energy. So again, we know that potential energy is equals to mass times gravity times height. And in our data, we have a mass m, which is 10 kg. We have height h, which is 2 meters. And what else do we have? We have acceleration due to gravity, which is g, G is equals to 9.81. Okay, so now you just replace here. So this will give you, we have, let me see. So we have potential energy is mass is 10. You should make sure they are all in SI units. So that 10 acceleration due to gravity 9.81 times the height, which is 2. So this will give you 9.81, 9.812. This will give you 196. So this is 196.2 joules. Right? So that is how you were supposed to work out question number 5 here. Okay, this is question number 5. We move on to question number 6. Trying to make the video as short as possible. So question number 6. Number 6, Gift applies a force of 50 newtons to compress a spring by 5 meters. So we know force is directly proportional to extension. So force of a 50, so this is 50, is equals to K, and the extension is 5. So we just divide by 5 by 5. Then K equals to 5 into that will be 10 Newton per meter. Okay, so that is how you're supposed to work out question 6. Very simple and straightforward. You get 3 marks like that. Okay, so that is question 6. Force is equals to KE. You have force, which is 50, and you have the extension, which is 5, and you do the needful there. Okay, so we go to question 7. Question 7. Okay, write one similarity and one difference between renewable and non-renewable energy sources. So on the similarities there, you're just supposed to say they are both from nature. So they are both from nature, meaning that they are naturally occurring. Both of them are naturally occurring, and they are neither created, or they can never be created or destroyed. So they are both from nature. So that is basically the similarity there. And on the differences are that renewable are replaceable and non-renewable are non-replaceable. Simple as that. Replaceable and non-replaceable. And that is how you're supposed to answer question number 7. Then number 8, give 2 examples of renewable and 2 examples of non-renewable energy sources. So renewable, those that can be replaced. We have hydroelectric and wind energy, for instance. The non-renewable, we have coal and fossil fuels. Okay. Question number 9. What are the effects of friction on the motion of a body sliding down an incline? So if this is an incline and body is sliding down, what will be the effects of friction? So, well, friction is acting in the opposite direction, which will cause the body to slow down as it is, or maybe I would say it slows down as it is going down, or barely will move, or it will affect its acceleration. So basically we can say friction affects the body's acceleration as it goes down, and eventually may slow down the object. Okay, so that is question 9. Friction basically slows down the object like that. All right, calculate the efficiency of a machine that has an input energy of 30 kilojoules and an output energy of that. So remember the formula for efficiency. We said output over input energy or work times 100%. So our output work in this case is output work is 2 So that is 2 kilojoules. 2 kilojoules. Our input work is 30 kilojoules. So this is 1000. So basically this is 3 zeros and 30,000. So we cancel the zeros, we remain with this, then we simplify that. All right, so this has to be multiplied by 100. So this is 100 and we have a percentage here. So we simplify. So this is basically 30k joules is basically 30,000 joules. Okay, and 2 kilojoules is basically 2,000 joules. Okay, so that is the conversion that we have made here, and we need to multiply by 100. So this gives us 6.66%, which can be approximated. So remember what I told you. So I put a bar there because it is repeating. So this can be approximated as 6.67%. Right, so that is the efficiency. So that is how you're supposed to do question number 10. It's just basically the formula: energy is equals to work out over work input, or energy output over energy input. So our energy input was 30 kilojoules and our output was 2 kilojoules, and times 100. So kilojoules is just 30,000. So remember the units for energy is joules. So it was easy for us to calculate like that. Now we go to question number that is what, 11. Critique the use of spring in everyday devices. So what you're supposed to answer here, just put it here. So here you're just basically going to talk about the elastic limit. So this is one of the factors why springs are not good for everyday use, because they have elastic limits. They easily, when you surpass the elastic limit, they break down. So yeah, but basically they are good depending on the metal that you are using, but most of the times it has to deal with the elastic limits. So that would be one thing that you would critique here. Then the alternative here would be hydraulics. So these basically use water or air to reduce the impact, maybe in cars. So mostly cars that use hydraulics have a good suspension, an easier, softer landing than those that use springs. So you can suggest hydraulics here. Yeah, so basically that's it. Then create a table comparing different forms of force, energy, and ways to calculate them. So here what you just do is maybe create a simple table like that. So maybe you say here is kinetic energy, and here you say maybe potential energy, and their formulas. So Ke is equals to half mv squared, and Pe is equals to mgh. So basically that is what you're supposed to do for question number 12. Then we go to question number 13. Question number 13. So this was a straightforward question. You are asked to calculate the force or the distance required for the beams to be in equilibrium. So for them to be in equilibrium, clockwise moments should be equal to anti-clockwise moments. So here, clockwise moments, so these are clockwise moments and these are anti-clockwise moments. So here you're supposed to consider the mass of the beam. So the mass is acting halfway of the beam. So the mass always acts halfway of the beam for a uniform beam. So this is where the 50 newtons was acting. So it was acting here. Then so you needed to find the distance from here to there. So which was basically, if this is 6 meters from here to there, then this is 2 meters, then this should be 4 meters here. And basically 2F is equal to 4 times 50, which will give you your force of, so this will be what, 100 newtons. So which will give you a force of 100 newtons. So that is how you were supposed to work out this one. So you basically divide by 2 there, and you will get a force of 100 newtons. So that is question A. Then B, same thing here. So here we have 7.5 times 18. So the distance from here to there is 60 times D. So 60 times D plus distance from here to the force there, which is 5 plus D. So this distance is 5 plus D times 3. Okay, so this is how you are supposed to set up this question. Then you say 7.5 times 18. This is 135. So 135 is equals to 60D plus you distribute. So 3 times 5, that will be 15 plus 3D. So 3D. So you transpose this, that will be 135 minus 15 equals to 60D, and 3D will add. So this will give you 63D. So this is minus 15. This is 120. So here you're going to have 120 equals to 63D. Divide both sides by 63 by 63, and you get your D as 1.9. So D basically is equal to 1.9. So that is how you were supposed to work out this one. Yeah, so D is equals to 1.9. Okay, so that is that. Question number 14. Question number 14. If 10 EG and EA is playing, if 10 EG is playing pull the rope with 10 EA, they apply forces of 50 and 52 newtons respectively. Calculate the net force. So this was straightforward. F net is equals to acting force minus opposing force. Okay, so the acting force, or maybe you can just subtract the 2 there, that will be 52 minus 50, which will give you a net force of 2 newtons. So this is how you're supposed to work out this one. So that will be the net force. And here you can determine who won the pull the rope context. Obviously, those that are pulling with a force of 52 newtons will pull the rope, because meaning that the force will be going towards, or the rope will go towards their direction. Okay, so that is question number 14. Question number 14. Then we come to question number 16. Number 15. If Martha, Nalmango, James, Joseph, Audrey, and Given have to push a car over a distance of this much for this time, and they apply these forces respectively, calculate the power generated. So we need to find the net force. So the net force will simply be adding these forces. That is 27 plus 51. It would give you 212 newtons. That would be the net force. And you also have, so this is our data. We have the force, we have the distance, which is 743 meters, and we also have time, which is equal to 360 seconds. So we're asked to calculate the power. So power is equals to work over time. So our work is force times distance over time. So that will basically equal to force, which is 212 times distance, which is 743, over the time, which is 360. and the power will basically be 437.5 watts. So that is how you're supposed to work out question number 15. And that concluded the test. So I've done the test in about 30 minutes. So meaning that you can do it in 2 hours. So, oh no, about an hour. So I'll give you an hour to do this test. So yeah, so basically I'm recording this at the same time I am preparing the test. So though the lesson will be available after you write your test, see you in the next lesson.